This is question 4. You have last year, market research showed that 8% of adults living in a certain town use a particular local coffee shop. Following an advertising campaign, it was expected that the proportion would increase. In order to test whether this has happened, a random sample of 150 adults in the town was chosen. The random variable x is the number of these 150 adults who say that they would use the local coffee shop. Assuming that the proportion of adults using the local coffee shop is unchanged from the previous year, state a suitable binomial distribution model to use. So in the first one, we are deciding that our binomial is, or our function, sorry, is a binomial. We are checking 150 adults, so n is 150, and we are assuming that the proportion that is the coffee shop is 8%, so 0.08. That's our binomial. Then they say the probabilities given by this model are the terms of the binomial expansion of an expression of this form. Write down this expression using appropriate values of a, b, and n. So this is a bit strange question. If we do the binomial expansion of this, we have that an n term, so let's say a plus b to the power of n is going to be, I'm going to just write the nth term. So the nth term would be, or the r term, for example, n over r, a to the power of r, and b to the power of n minus r. That's the r term, yeah, of this binomial expansion. If we compare this with the formula of the binomial distribution, this is the probability of x being r, yeah? So in this case, if we compare, I would say, if we compare this with our binomial, and we use the numbers of our binomial, this would be 150 over r. A is going to be 0.08 to the power of r, and then b is going to be 0.92 to the power of 150 minus r, if that makes sense. So if we compare this with this, we see that m is 150, so they are asking us to find n, r, a, and b. A would be probability of success, which would be 0.08, and b would be probability of failure, will be 0.92. Yeah, and this is really what they are asking us. We just need to realize that when we expand a binomial expansion and we have the general term, this corresponds to the probability of a binomial being r, yeah, and that's it. It's simple but a bit strange question. And then it was found that 18 of these 150 adults say that they use the local coffee shop, and we have to do a test, 5% significant level, to see if the proportion of people that use the cafe has increased. So our hypothesis testing is going to be 80 proportion is still 0.08, but H1 we want to check if it has increased. Its significant level is 5%, and the observed value is 18, right? If this is true, this is going to be a binomial 150, 0.08. So what we are going to check is the probability of x being greater or equal than the observed value, which is 18. This is not in the calculator, so we are going to do x minus 17. And we go to binomial CD. N is 150, P is 0.08, and X is 17, and we do 1 minus 0.945, which is 0.055, which is greater than 0.05, so we have to accept H0, which means there is not enough evidence to say that the campaign was effective. Something like that. The campaign was effective. It's not enough, yeah? We will need more people going to the cafe to be sure that this was effective. And then, what else? It was later discovered by statisticians that the random sample of the 150 adults has been chosen from shoppers in the town on a Friday and a Saturday. Explain why this suggests that the assumption made when using a binomial model of X may be not valid. I would say that in this case, we can say that the sample was not random, or the probability of this was not constant. For example, because maybe the results on Friday and Saturday are completely different than on Monday and Tuesday. Yeah, so maybe different days give us different probabilities. Yeah, so maybe different days give us different probability. Yeah, so the 0.08 would be different probability. Yeah, or something like that. And that's all with this question.